Hello OrganArc students, we're going to dive back in with our next integrated circuit here. Before I dive into the next one, I realized at the end of the last video I forgot to actually make the integrated circuit. So you can go back and highlight all of your pieces of your full adder and then create your integrated circuit full adder. There we go. So there you go, now you have a full adder circuit that you can use as well. The next circuit we're going to talk about is one that may not be intuitive. Adding is, of course, a critical piece of anything that involves numbers. The next one, though, is called a 2 to 4 decoder. And the idea here is either you could think of it as converting from binary to decimal. So 0, 0 is 0, 0, 1 is 1, 1, 0 is 2, and 1, 1 is 3. You could also think of it as basically enumerating our options. We have two inputs with two binary inputs. We could choose or select one of four outputs, one of four different values that we can use. So we can really use these to sort of select something, right? So I want to select the 0th thing or the first thing or the second thing or the third thing. And for that, I only need 2 bits. So we can basically turn 2 bits into four selections, right? And if we had a third bit, we could go to 8 selections. And if we had a fourth bit, we go to 16 selections. And so what this is really doing is kind of decoding that. And so if we actually look at what this circuit would do, it turns out it's fairly simple. We just want 0, 0, 0, 0 as inputs to be an output of 0, and 0, 1 to be 1, and 1, 0 to be 2, and 1, 1 to be 3. So if we pop over here, first thing to do is figure out how many inputs and outputs do we have. If we want to build the circuit, we have 2 inputs. So we'll bring in our 2 inputs here, and we'll have, I guess we can call it A and B if we want to. Let's stick with A and B, I suppose. So A and B. I'll go ahead and pull in labels. And actually, you know what? I'm starting to think maybe we should call this. Yeah, no, we'll call it A and B. We'll stick with it. So we'll do A. We'll do B here. And then our outputs, we want to choose one of 4 things. And so what we really want to do is represent the sums of all these things. And I could just use a number 0, but then it's a little confusing. I'm going to call it O0, which is maybe slightly more confusing. I don't know. But O0, think of it as output 0. Make it easier for labeling later. You call it out 0, I guess. Maybe that'll look nicer. Let's go out 0. Alright, and then actually one thing I haven't shown you is that you can highlight and copy and paste, especially if you're copying labels and things. Maybe a little quicker to do this. I'll change out 0 to out 1, and out 0 to out 1 on the label. And then I'm going to go ahead and copy and paste 2 at once, because I know I'm going to need 4 outputs. So I'll make this out 2, make this out 2, make this bulb out 3, make this label out 3. And so all I have to do is figure out the wiring, right? So when should out 0 be on, when should out 1 be on, when should out 2 be on, when should out 3 be on? Well, it turns out that the wiring for this is not too bad. Basically, we're looking for specific combinations of A and B. And so we can just do an AND gate for each of these. We just have to figure out what is that timing, what is the frame, what are the inputs that should make each of these light bulbs light up. So we know we're going to have to do when A is 0 and when B is 0 at various points. So I'm also going to bring in a couple of NOT gates. And so now let's just think about this. So out 0. So what plus what, or in binary, what 2 values give us 0? Well, 0 and 0. So if A is 0, meaning that if A makes it through this NOT gate, and B is put through the NOT gate, then this AND gate turns on. So if A is 0 and B is 0, then we want to turn on out 0. I guess I'll move it up just a smidge. There we go. Probably have to do that for each of these. Although this labeling thing is really in the way. So we'll move each of these up just a little bit. So if A is 0 and B is 0, we turn on out 0. So actually, I used A and B, and I was kind of a little hesitant about it, and here's why. I really want to know which one is bit 1 and which one is bit 0, right? If we're doing, if I flip back over here, are we doing 0, 0, 0, 1? Let's call this N1 and this one N0, because really this is out 0, out 1, out 2, and out 3. So I want to call this 1 and 0 because I want 0 to be the least significant bit, the smallest number, right? So if we're thinking about this as a binary number, 0, 0, the largest bit is this first 0, and the smallest bit is the second 0, right? This represents 2 to the 0, and this one represents 2 to the 1. So N1 represents 2 to the 1, and 0 represents 2 to the 0. So I want to make sure we line it up this way. And I guess with my current labels, I was thinking of A as N0 and B as N1. Let's change the numbers to make sure the rest of this makes sense. So I'm going to go back and change this. Instead of A, I want to make this N0. So I know that this is my input 0, and I know that this is input 1, from least significant to most significant. So let's call this N0. Let's call this N1. All right. So maybe these labels now make a little bit more sense. So if I want an output of 1, then in binary, that would be the most significant bit is 0 and the least significant bit is 1. So I'd want what I already have here, negative. I'd want a NOT gate on my my most significant bit, because I want this to be 0 and then 1. And then I want the positive version of my least significant bit, my N0. And that gives me out 1. So this helps me. If you have a different way of organizing this or thinking about this, please do. I tend to like this version, but if you like a different version, that's fine. I just like doing the least significant or smallest thing up top and the largest thing on the bottom. So in this case, we can verify these 2 points. 0, 0 lights up 0, and 0, 1 lights up 1. So again, I'm thinking of N1 is the most significant bit and N0 is the least. And by the way, you can do things too, or if it helps, you can try to rotate these. If you try to rotate it like this and line this up as the least significant bit, and rotate this, rotate this, and make this the most significant bit, that might make more sense to you when you're trying to do the math as well. In fact, for the sake of making things simple, I'm just going to keep it like that for the rest of this. So if I get 0 and 1, then I get 1. And so then the next thing, so what would give me an output of 2? Well, if it's 2, the most significant bit has to be a 1, so if the most significant bit is on, and the least significant bit is off, so I'm going to go ahead and pull from that NOT gate that I've already set up for the least significant bit. So if I get 1 and then 0, then that's 2. So that should light up out 2. And then out 3 lights up for 1, 1. So N1 is 1. And N0 is 1. So if both of these are 1, then we have a sum of 3. And so if we wire this right, our little decoder here could go 0, 0, 0, 0, 1 is 1, 1, 0 is 2, and 1, 1 is 3. So there we go. So that's our 2 to 4 decoder. Again, however you have it oriented is completely fine, but you can highlight all your pieces, create my integrated circuit, and call it a 2 to 4 decoder. All right. So now you can check and make sure it got added into your circuit here. I accidentally added two full adders, so I'll delete one of those. So I have a 2 to 4 decoder, half full adder, and a half adder. All right. See you for the next one.